This is gases video number 2. By the end of this video, you'll be able to describe how gas pressure is measured and calculate the pressure of that gas. To do this, you're going to need your video number 2 worksheet and a pencil, because it is always due the next day you have class, and a calculator could be helpful. There are 2 devices that you can use to measure the pressure of a gas. The first one is called a barometer, and it is used to measure atmospheric pressure. This is what you may have heard them talk about on the news when they're talking about the weather. And it is the pressure of all the gases total in the atmosphere combined. The next one is the manometer, and it is used to determine the pressure of an enclosed gas. Barometers. The first barometer was made by taking a tube that is sealed on one end. It has no gas on the inside, totally a vacuum, and placing it into a container that had mercury in it. By having the mercury inside the tube, you could figure out how much pressure it took for a normal day to be pressing down here. So the atmospheric pressure is pressing down. There's a certain amount of pressure there. And it forces the mercury up into the tube to a certain distance. Now, this particular one shows 760 millimeters of mercury. This is a typical or a standard day. So this is called standard pressure. Now, one way we describe it is 760 millimeters of mercury. Millimeters, because it is how far up the mercury traveled at sea level on a standard day where the first barometers were designed. There's another way to describe this. This is also equal to 760 torr. Torr was named after the person, the scientist who came up with a barometer. Another name, though, for this is 1 atmosphere, or 1 ATM. And that's the way that chemists usually describe it. So you should be able to convert between any one of these units. Manometers are different because they have an enclosed gas. Now there's 2 types of manometers. There is the closed manometer and the open manometer. And you will notice that they look essentially the same. The difference is right here. If it's closed, this is going to be sealed, and there'll be no air in the inside. It will be a vacuum. These are open, and the atmosphere, or the air from the atmosphere, can press down with a certain amount of pressure. So the air is going to push down. Then there'll be some sort of flask that has the gas that you're being tested. Depending on how much it pushes down and up will determine what it is. So this one, the distance, so how high up it goes, is equal to the gas pressure. But this one, how high up it goes, is going to be the difference between gas and air pressure. So the delta H is equal to the difference between gas and air. Let's do a couple of problems. First one, you could have a question like this. If the atmospheric pressure is 765 millimeters of mercury, what is the pressure of the enclosed gas? But notice how it is closed. Closed because it's sealed. So the air pressure, or the atmospheric pressure, has no impact at all. So I really don't even care about this. The gas pressure is 365. The pressure of the gas is equal to, 361 millimeters of mercury, or 361 torr. Or if you wanted to, 361 torr times by, remember we said earlier, 760 torr equals 1 ATM. And then you could do 760 torr and 1 ATM on the top, and find your value in ATMs by doing factor label method. The next one, the open one, is different. Same question. If the atmospheric pressure is 765 millimeters of mercury, what is the pressure of the enclosed gas? Now keep in mind here, this height is not the pressure. We have pressure of the air pushing down. So pressure of the air, or the atmosphere, is 765 millimeters of mercury. The gas is also pushing down, but we don't know what his value is. We just know the difference between this and this is 15.8 centimeters. Now right here, centimeters, millimeters, not the same unit. We want to convert. So 15.8 centimeters times by, we know to convert, the units have to cancel. And then back from our days, we know that 1 centimeter is equal to 10 millimeters. So 1 to 10, 158 millimeters. So this becomes 158 millimeters. Now, in this case, you want to find out who has more pressure, the gas or the air. The gas pushes it down all the way to here. The air only pushes to here. So in this case, pressure of the gas is greater than pressure of the air. So this difference would be pressure of the gas equals pressure of the air plus that height difference. So the pressure of the gas is pressure of the air, 765 millimeters of mercury, plus our height difference, 158, and you add them together to get your overall pressure difference. From here, you can convert it into torrs or ATMs.